Hello, everyone, and welcome. Today we are going to continue on with our lessons with string processing. Now, you may feel like, how come we're not just moving on to the for loops right now? And the reason is because the looping with the for loops has a lot to do with cycling over the strings as data structures. And so we are going to take a little bit of a deviation into learning a little bit about the strings and how we can understand the strings in terms of individual characters and how we can pull out those certain characters and do other interesting things with them. Python has quite a few built-ins that we're going to take a look at before we move forward with the string processing, which will involve the looping, but they are somewhat inextricable. So you may hear a little bit of spoiler alerts for the continuation on with our flow control. All right, well then, let us go ahead and continue on. I'm going to share my screen, and as usual, you are invited to follow along in whatever way suits you best. I am right here in the string processing, strings as data structures. So this is definitely not the first time that we have seen strings. So I thought it would be helpful for us to maybe take a little bit of a second look at the strings in the ways that we've already seen them, and kind of just put all of that together and look at that a little bit retrospectively, because now there are so many other things that you know how to do, because we kind of look at those as individual things. Now we can kind of put that together with some of the processing, like if statements and so on, that you've been encountering. So we're going to spend a moment recalling what we already know about the strings, and then we're going to take a look at some of the built-in string functions. Next time we'll do the indexing and slicing, and then we're going to have a little bit of information about the comparison and then in the following week we will return to some of the looping structures that are available for working specifically with the strings. So then let us move on to our string reprise. So there's a number of things you know how to do with them already. We've seen print from the very beginning, and print just allows us to make a textual representation on the screen. Here is an example of a print. We remember that we're going to put a string inside of here, right? And so print only operates on the strings. And we remember seeing quite a lot about what if you print something that's not a string, how Python will so helpfully try to call the string coercion on whatever it is you're trying to print. So usually coercions work pretty well from other stuff into strings, but strings into other stuff doesn't always work so great. So that means print is usually reasonably robust though. And also don't forget that when you have the comma inside, so if you do print something, comma, something else, that it will insert the space for you. Another example of Python being so helpful, which usually is. And also another thing that we're illustrating in this in particular is that we can be sure to match the type of quotes. So if you need to have an apostrophe on the inside of the thing that you're trying to print, that we should use the double quotes so that the single quote will not terminate your string and cause an error if you had chosen to use the single quotes. Another thing we know how to do is we know how to get input. So here is getting some input about Big Lake, right? Which of the 5 US Great Lakes is the largest? And so the user is expected to type some answer to that. And here they have answered Superior. And then we can get out the value of the thing that's in the variable by then typing the name of the variable. So of course, input doesn't have to be used with a variable equals syntax, but this is oftentimes how we use it. And the reason is because we want to capture whatever the user types into the variable, and then we can take that variable and use it. So input, just like print, will use only strings. And also the prompt that we provide for it is also a string. And of course, this can cause a bit of a problem if we want the user to type numeric input of type into a float, and perhaps also with the Boolean, because the type would be type string, and so it's not going to have the properties as the thing that we want to have. So we saw then how we can apply the coercion functions to deal with that, and that can help to convert things to the form that we want. But of course, that precludes that they actually type something that can be coerced. So, you know, I say type an integer and they type ONE, Python's not going to know to turn that into the integer 1. So, you know, there can be some problems with that, but some of our string processing and some of our if statements and so on could be quite helpful for some of these things. All right, so that's the input. We have also seen coercion to type stir, and so this follows from a number of the things I was just mentioning. So here we have some variable Lake Michigan depth equals 281, and then we can ask what the depth is, what's the value of this variable, and it reports back 281 as an integer because that's the type that they had typed, and we can verify this using type. But suppose we want to coerce it to a string, and so this is what we were saying about the printing. So here we wish to print a sentence, the maximum depth of Lake Michigan is, and then to fill this in with the actual value and then the word meters after. So this illustrates how we can have commas separating several items to print, and that Python will actually insert these spaces for us, which we can see between these two, which is done here, and I have a space here and this, so we actually get 2 spaces here. And so the problem is the type of this is int, as we've just seen up here. So what's going to happen is going to print the integer. Is that going to be fine? Well, as we saw before, it will simply just apply coercion for us. So it will call the stir on the value of Lake Michigan, which is an integer, and that's how we get this 281. Now it's implicit because Python did it for us. If we had done stir of Lake Michigan depth explicitly here, as we did in some of our exercises, then it would have been an explicit coercion. And here's an example down here. So explicit coercion to a string. Here's Lake Michigan depth. String equals Lake Michigan depth, right? So we've called stir on the Lake Michigan depth explicitly, and then we can verify that the original Lake Michigan depth had been an integer, right? So Lake Michigan depth is still an integer because we're capturing this in a different variable, and then we can check the type of our string variable, which should be the string equivalent, which it is, which we can verify here. So of course, type is very helpful in verifying the type that things are. We have also done concatenation. We can use the plus to do concatenation, which we normally would associate with numeric types. So it's not too much of a stretch of the imagination that plus would work on ints and floats, but what does it mean to work on strings? Well, that is the spirit of the object-oriented programming. You can have certain things that are defined to do with other things that you may not even expect to work with that. And so it kind of makes sense that plussing should like bring the things together, and that's how we have concatenation. So here we're illustrating team equals green plus bay plus Packers, right? We get this concatenation of these various pieces together. We also have similarly the repeat. So again, the star is for multiplication in math, and so it's overloaded by the object-oriented programming style because this particular one also has code associated with the star operator. And so the star operator is going to make this, whatever string you provide to it, repeat that many times. So here we have team plus an exclamation point, and then we're going to have, we're going to plug in the value of team, which we had Green Bay Packers from before, and then we'll have the cheer print out 3 times, so we get 3 cheers for the Green Bay Packers. We can also test things for equality, and this again is overloaded to work with strings. We've checked to see if things are exactly equal or not equal already. So our Green Bay Packers, the same thing as the New England Patriots. Well, if you're a New Englander like me, you definitely don't think so, but I've lived in both places, so I'm not saying which. You may have opinions on these, but anyways, from the string point of view, this of course is false. So there are more things we can do with strings we haven't yet seen. There are a number of built-in functions and modules for working with the strings. And we've been talking about the types, and I've kind of been alluding to the object-oriented programming. And the way it works in Python is when you have something that is of a particular type, you have certain things associated with that type. So there will be certain code built into Python that is associated with that certain kind of a type. And if you go on for more advanced programming, you'll learn that in Python, you can invent your own type, and then you can invent whatever you want to be associated with it. And that's part of how Python can be a very flexible programming language. But for now, let us take a look at some of the built-in functions for the built-in types that are available for the type called strings. So there is the length function called len. The length function returns the number of characters in a string. Alphanumeric characters, spaces, and punctuations all do count as the characters, but the quotes on the outside do not. And there is also such thing as the empty string. That's just 2 quotes with nothing inside, and the length of that is 0. So you would get the length of something by doing length of the string. So here is length of a string containing 5 digits, and that's 5. 1, 2, 3, 4, 5. Here is the length of 1, 2, 3 with some punctuation in here. So notice that we are counting over all of the numbers. The commas also count. We have an exclamation point that counts, and the spaces count as well. We have 3 numeric characters, 3 punctuation characters, and 2 spaces in between to sum up to a total of 8. And then we have the length of this here, which is the empty string, which is 0. Now let me just point out that the empty string does not contain a space. Sometimes it looks like it has a space, and this can be a little bit difficult to convey, and it's harder to see in some fonts rather than others. So what I like to do is I like to put a little note next to it, empty string, anytime there may be some confusion, and you may also want to get in the habit of doing that, especially as you're getting started. And you can have the empty string with the single quotes or the double quotes. The problem tends to be more pervasive with the single quotes, because you could look at this and say, oh yeah, there's a space in there. That's why it's empty, because it's the empty space. No, that's not what it is. There isn't any character there. So just pay attention to that. Interestingly, the empty string will become important as we talk about accumulation using strings when we get to the looping next week. So the general string method syntax is the variable name dot and the string function with the parentheses. So this is what we call the dot notation. And so this works with things that are programmed into Python as a method, which means it's encoded in a slightly different way. How that works in terms of the encoding is not something you specifically need to worry about, but you need to be aware that there is this kind of notation. So when something is coded as a method, then this is how you're going to access it using this dot notation. So for example, if we have some string, S equals the string Huron, and then we do S dot upper, we'll get everything in uppercase. So let's just take a moment to see how this works. So you have the variable here, right, dot, and then you have the upper over here. I'll also mention that a variable, of course, is going to just return a value into it. So when Python is actually doing the uppercasing, it's doing it based on the value of the variable. So you could just have some string here already. That's also a possibility. And so what this is going to do is it's going to return it in the uppercase. And we're going to see that there are a number of functions that are going to, or I should call them methods more appropriately, that follow the syntax. We have the variable name, the function or the method name, and then the parentheses. So functions and methods are very similar to being the same thing, and the difference can become apparent as you go on in programming. It's whether or not it's connected to a certain type or not. So here's one of our first string methods. There are a number of them that return Booleans. These ones you can kind of think of as asking a question, and you can recognize them because they begin with is. So isDigit is asking a question, is this a digit? It will return true if all the characters of a non-empty string are numerical characters. So here we have 1, 2, 3 dot is digit. Is 1, 2, 3 full of digits? Yes, so we get true. And is ABC full of digits? No, it's not, because they're alphabetic characters, so we'll get a false. We also have is alpha. This will return true if all the characters of a non-entity string are alphabetic. So is 1, 2, 3 alphabetic? No, so we get false. And then ABC, this one is now true. We can also ask the question, are all of these in lowercase? And so we'll do ABC dot is lower, and that returns true. And now we're going to do ABC dot is lower. So there is a lowercase one in there. What's Python going to do? So it tells us false because they're not all lowercase. Is upper similarly will return true if all the alphabetic characters are in uppercase. So you can do ABC dot is upper, which is true. But if you do this of Abe in a title case or name, we'll get false because 2 of them are not. There are also additional string methods. We also have upper. So we have is upper that returns true or false to tell us whether it already is upper. But upper is more like a coercion function that tries to cast things into being in the uppercase. So we can take a look at upper. This is going to return the alphabetic characters in the string in uppercase. So here we have Chicago dot upper, and we get back Chicago all in capital letters, just like the sign in Chicago. And here we have root 66 with 1 cap, a bunch of lowercase, and also some digits. What's it going to do? So it will leave the non-alphabetic characters untouched, and it will capitalize all of the alphabetic characters. So here we see it has converted the root into capitals. We also have lower. So lower, again, is like a coercion function because it will cast things into the lowercase. Lower returns the alphabetic characters in the lowercase. So E. Cummings is a poet that was famous for only using lowercase. So we have this sentence about all of his poems, and we are going to say this expression dot lower, again using our dot notation. And here we see that the punctuation, the spaces, actually I guess there isn't any punctuation, but punctuation also isn't affected. The numeric part remains unchanged, but anything that had been capitalized that was an alphabetic character now appears in lower case. All right, well then, thank you so much for joining. I hope that this was a helpful review of the strings and a good look into that new idea of the methods. It's nice to be back in some familiar territory working with the strings. We will soon be seeing more about the strings. I bet you never knew there was so much you could do with just a simple little text. And we will then be continuing on with the looping over the strings in the subsequent week. Thanks so much, and we will see you the next time.